Start recording. All right. How was your weekends, ladies and gentlemen? Hopefully you had the fall colors are really turning out nice. It's a beautiful weekend. I'm glad you had a good time. So just to let you guys know, next weekend is a 3-day week. 3-day weekend. 3-day. That's not three. That's a pound sign. 3-day weekend next weekend because October 9th is Columbus Day. Not sure I've never had Columbus Day off, but we have Columbus Day off. So hi Oz. So we're having a holiday, so 3-day weekend. So and then 4 days class this last week. So this week's a tough week. I can tell you it's a tough week. You guys are gonna have to really work hard um, to get this stuff done. Okay, so it's full of math. Well, I love math, but not everybody loves math as much as I do. But integers, using integers and trying to figure out. But this is really important stuff. So you have to work hard on this. Don't give up. You can get it. It'll come to you. So let's take a look at what happens to this week. So I can review ions, cations, and anions. We've talked about them a little bit. They'll get into more detail, but you need the vocabulary words there. I can identify isotopes and count the number of protons, electrons, and neutrons with the pens, which is protons, electrons, and neutrons. So isotopes are really important because we use isotopes. Most of them are radioactive. We use carbon-14 to measure um, the age of fossils. We use some of these isotopes in medicine to put in as a dye, a radioactive dye, so we can treat diseases. See how you look inside from your veins and so forth. Hey, Jeremy. And then ions transmit nerve signals and contract muscles like the heart. So you need to have ions in your blood in order to conduct electricity. So you'll see what's happening here. We've got calculations today, determining isotopes, and then we have test review, and test review because this week we have Chapter 7 test, which is parts of Chapter 4, parts of 5, and weeks 5, 6, and 7. So there's a lot of stuff. There's 20 questions, 3 points each. So it's 60 pointer. So that's what's going on this week. So I'm hoping you guys are doing okay. We've got 18 people. Hopefully you guys are willing to do some work today because, like I said, if you can get this information going here, you can be successful, stay focused, and work hard. So here's your link, right? I'm going to give you the P-table link as well. P-table is useful to have so that you can use your periodic table. P-table. I'm going to keep mine up. So I'm trying to demonstrate this stuff so that you guys can understand how to use it yourself, right? So hopefully 18 people. Good morning, Aaron. Afternoon, Aaron. Hey, Austin, I haven't seen you in a while. How you doing? Hey, Oz, Brent, Haley, Jalel, Jasmine, you guys are all here. Jeremy, Kamaya, you guys are all hard workers, I can tell. Lillian, Madison, Mariana, how's that computer? Still lagging and stuff? And Shayana, Shalea, and Tanisha, and Ty. Victoria. Victoria, how are you doing? So today what we're going to be doing is going over some um, kind of test questions for the Ohio test scores. Ohio does a lot of testing, and they use this chemistry stuff in biology, which you'll have next year. So this is something that even if you don't take chemistry, this shows up. All right, you may have had an 8th grade. So here we go. We got 7 out of 18. I'm going to put my clicker here on, so you're going to hear some sounds in the notification that when users join, and then the chat messages so that I am notified that people are asking me questions. No, you guys are working hard. You guys are working hard for sure. So, all right, so let's go at 7 out of 20. So we had a third of the class. If we can get more than that, that'd be great. So Mr. Barnes did the notes this week. So he just loves this stuff here. The what would you call it? The fantasy stuff. He does love. So he puts those in there. So most of what we're talking about isotopes will be between 10/2, the today's date, and 10/3. So here's the bulletin. Friday, test chapter 4, 5, 6, and 7. So anything from chapter 4, 5, 6, and 7 is in there. All right, so I'm going to review cations and anions with you. What's the difference between an ion? I can identify isotopes and count protons, electrons, and neutrons using the Penn's method. So we're going to use that. And again, it seems pretty straightforward, but it's like I said, some people say it's kind of confusing. So, so this is what I'm talking about. We have to key terms: atomic number, mass number, atomic mass unit, atomic mass, and isotope. So on this next one, if you would be so kind, tell me which one you think that you need some help on. So this is going to be my first points for you guys. So like this is, if you can put this in, this is an easy way to contribute to what's going on in the class. All right, so I'm going to put down, give it a chance, you guys, to tell me which ones, and I'm going to put your name down. All right, so that you are working on. So this is Monday. And that's week 6 advisory. Here we go. Week 2, week 1, week 1. Where's PS6? There we go. Monday the 2nd. And we've got Haley. Thanks, Haley. Haley's put down something here. Yeah, so that is something that makes it's difficult getting that information. Okay, Kamaya, got you down. And who else do we got? We've got Shalea. Thanks, Shalea. Thanks for being honest on that. Where are you? H. There we go. Monday. And we've got Madison. So we got 1, 2, Madison. Only did I get only 5? I got 7 people listed, but not everybody is putting in there. All right. Right. Remember, the bonuses comes in October 20th is the 9 weeks, and that's where the bonuses go in. So this is kind of one of those things that you can do. So we've got 5 out of 12. Come on, ladies and gentlemen, that was all. Your brain is offline. Well, let's try to get it online. You can turn that around anytime. Okay, 5 out of 7 out of 12. Okay, so let's review quickly what we already know about ions. Okay, so ions are something to do with electrons. So electrons and ions. Okay, so if we look at this is the symbol O. This is oxygen, right? Normally we say it comes out as a neutral atom. Okay, a neutral atom means that the protons plus charges are equal to the electrons. So in this particular case, this doesn't happen. So there are 1, 2, 3, 4, 5, 6, 7, 8, right? There are 8 protons here, but only 1, 2, 3, 4, 5, 6 electrons. Okay, these cancel each other out. So in 5 seconds, would you please, in the chat, in 5 seconds, I'm going to count down. I want you to put down whether it's a +2 or a -2. In 5, 4, 3, 2, 1, 0. Everybody put it down. Okay, I only got two responded. Thanks, Kamaya. Thanks, Haley. Okay, so the reason that I did that in time there is so that everybody is ready to go. So these cancel these out, right? So it is a 2 plus, right? Right, it's a 2 plus, 2 plus. There's a charge. This positive cancels out this negative, this positive cancels out, but we have 2 pluses here. So this would make it positively charged. Okay, so like rubbing your hand on your hair, putting a balloon to your hair, you get a charge to it. And you might get, it's hard to say whether it's a positive charge or a negative charge, but if it's positively charged, it's called a cation. And what I like to say, it's positively charged, positive, okay, positive. So cat and pause. Okay, so if you see something that looks like this, oxygen +2, along with the numbers of 8 and 16, that tells you it's an ion. Okay, it has a positive charge. Sometimes they'll just have nothing there, or sometimes they'll have 0 there. 0 means it's neutral charge. And like some people have done in the FET, they think that a neutral charge means there's no electrons. Well, remember, we've got positive and negative charges. If there were no electrons, this oxygen would be oxygen +8 because it's all protons, no electrons to cancel out the charge. Okay, so anions are electrons that are negatively charged. So this would be something like this. So let's take a look at how an anion looks. Let's go on to the next thing here. All right, and I want to make sure that my sound is on. So I got to do this, turn it on and off all the time so I can make sure every time I click, it clicks off. All right. Okay, still not sure, but here is.
Students love learning with Prodigy because it makes math so much fun.
All right, just a couple minutes here.
By comparing the number of protons to the number of electrons, we can determine whether the charge of an atom is positive or negative, and also can calculate the total charge of the atom. For example, if a chlorine atom has 17 protons and 18 electrons, there are 17 positive charges and 18 negative charges. Adding the two results in a charge of -1. The -1 would be expressed as a superscript of the atom. Conversely, if an atom has 24 protons and 28 electrons, there are 24 positive charges and 28 negative charges. Adding the two results in a charge of -4. What is the charge of an atom with 8 protons and 10 electrons?
Okay, so is it A, B, C, or D in 10 seconds, ladies and gentlemen? In 10 seconds, don't put it in yet. Don't put it in yet. Clear. Okay, 10, 9, A, B, C, or D, 8, 7, 6, 5, 4, 3, 2, 1, go. Put them in, put it in. Nope, didn't do it. Didn't hear me. A, B, C, or D? Okay. Thanks, Haley. You were right, and everybody followed on. The reason we try to do that is So not everybody, so everybody puts the answer in at the same time. So it is a -2 because there are two extra electrons.
Sir. That is right. The correct answer is B, -2. 8 positive charges plus 10 negative charges equals 2 negative charges. Now let us look at it a different way. Which of the following is an atom with a charge of -3?
Okay, so an atom of -3. Is it? Okay, so I'm going to do this. I'm going to have you guys do this in the private chat only, private chat. Okay, is it 1 electron and 4 protons? Is it 1 electron and 2 protons? 4 electrons and 1 proton? 4 electrons and 4 protons? Okay, so I can help. I don't know if I can write on this. I don't think I can. All right, so what is it? A, B, C, or D? In the private chat. In the private chat, A, B, C, or D? Actually, you know what I think I'm going to do? I'm going to do a start a poll. Let's do this. A, B, C, or D? Let's do this. Okay, and there we go. Is it A, B, C, or D? Okay. Thanks, Jalal, Shalala, Gavin, Haley, Joseph. Thank you much for putting those in there. Okay. Thanks, Lillian. Okay. So, anybody else? We've got 10 people. Thanks, Jasmine. Christian, thank you. Oz, thank you. What you got? Joseph, Haley. Okay. Anybody else? 12. Okay, we could get Ty and Tanisha, Mariana, Madison, Luli, Kamaya, Kaylee, and Brent in there if we could. All right, we're getting some more. Okay, let's show what this is. Okay, so the poll says that I got six people said B, 1 electron and 2 protons. That's a +1. Okay. 4 people said 4 electrons and 1 proton. That's a -3. So it's 4 electrons, 4 negatives, and 1 proton is a -3. So the letter was C. Some people said it was 4 electrons and 4 protons, which would cancel each other out. That would be 0. Okay. That happens. That happens. Thanks, Kamaya. All right. So it looks like we need some help on that for sure. Okay, that's what we need help on. All right, so
Very good.
we're gonna.
The correct answer is C, 4 electrons and 1 proton. 4 negative charges plus 1 positive charge.
All right, there we go. Okay. Okay. So let's take a look at +2. Okay, so first off, we have to do is we have to look at the periodic table. Okay, we have to look for calcium. Calcium has 20 and 40. So let's go back here to calcium with 20 and 40. Okay, so we know calcium has, all right, so it has atomic number of 20 and 40 for the atomic mass. So the mass number is 40, which is protons plus neutrons. And this is the atomic number, which is the protons. Okay, so first we would do is we write down 20 protons, right? And then because the mass here is 40, we're going to take, that's the protons. So it says 20 plus the neutrons equals 40. So I'm substituting in. Oh, that's Mr. Barnes is interested in a lot of games and So that's what he does, and that's what I'm showing you. So this is going to be 20 neutrons here. Now here is where we have to figure out the plus. So we have 20 plus charges. So 1, 2, if we can think of 20 pluses, right? What can I put in here so it comes out to be a +2? Okay, so I got to put my negatives in here. Anybody have an idea what I need to put in here to end up with a +2? So 20 minus some number gives me a +2. Nope. Minus 22 gives me a -2. Very good. Good try. Thanks, Joseph. That gives me a -2. I want a +2. So it's like I have $20. I spend some money and I've got $2 left. Yeah, there you go. 18. Right? 18. Okay. So that's how we get that information in the periodic table. All right, let me okay, I'm gonna do this. I'm gonna go do this again. Didn't want to do that right away. I messed up. Okay, so let me do this again here. Okay, so what we've got is, so remember, and the periodic table it said 20, 20. Oh, I can't write today, huh? 20, that's my atomic number. That equals the protons. 40 is my atomic mass. Atomic mass. And I didn't spell that right. Mass, which is the protons plus the neutrons. So we're going to put the 20 in there plus the neutrons. That makes this 20 and 20. And we figured 18 electrons gives us a +2. That's a cation, right? All right, so chromium, let's go back to the periodic table. Cr, right there, chromium is 24 and 52. I'm rounding that. 24 and 52. So my atomic number is 24. So that means I put that for 24. My atomic mass is 52. So my atomic mass is 52. So that is 24 plus some number gives me 52. Anybody know what that would be? 24 plus some number gives me 52. Put that in the chat. 24 from plus some number. Now we can do this as just subtract 24 from it, right? 52 minus 24. Anybody? Thanks. Close. So 6 would make it. So 4 from 12. So pretty close. 28. Okay, so 28's my neutrons, because that, remember, is the total of the atomic mass of 52. Now, electrons +3. So I've got 24 plus some number, or I should say minus, plus a negative. Let me do this again. See if I can erase that real quick. Yep, I can erase it. Minus some number gives me 3. What are we going to do there? 24 minus some number gives me 3. That'll tell me how many electrons I have. 24 minus some number, X. What do we get? Yeah, thanks, Jasmine. 21. Okay, so we have less electrons than protons, right? So we get a +3 charge. Okay, so this one's the last one, sulfur. Let's go to the periodic table, and sulfur is 16 and 32. 16 and 32. 16 and 32. Okay, so I'm going to put in 16 protons. So my atomic number is 16. That's my protons atomic number. Just to remind you, atomic number, I'll put NO period. And 32 is my protons plus my neutrons. So I got 16 protons plus something gives me 32. So I can do my algebra, right? So let's say that's x, 16 plus x. I subtract 16 from both sides. So how many neutrons do I have here? Thanks, Jasmine. 16. Okay, so now what I've got 16 protons minus some number that gives me -2. So it's like I go in the hole. I got $16. I'm going to use all $16, right? Ah, there you go, Oz. 18. Good job. 18 electrons. So if I have more electrons than protons, it's an anion. Okay, if I have more protons than electrons, it's a cation. Okay, so that's what we're talking about. That's the the difference in the ion, and these are the things that that show up on the. You take a picture of this. These are the things that show up on those Ohio State tests. They need you to know how to do this. So we're going to take an exit quiz on this today. And then I'm going to put people in breakout rooms tomorrow so that we can understand, help people that are struggling with this. Okay, so and I've talked about this before, atomic mass is the 12 here. It's the total of something plus neutrons. Okay, so tell me in the chat, what is it that something plus neutrons, what is it that goes here? Is it electrons or protons? Electrons or protons in the chat? Electrons, E or P? So give me an E or P on this one. Electrons or protons go here. Something plus neutrons is equal to the atomic mass. E or P? Well, let's do it this way. Let's do a poll real quick. All right, 2. So we're going to either put E or P. Take care of this and that. E or P. A is E for electrons. B for P. It's supposed to be P. I got O. All right. So Madison, thanks, Madison. Mariana, okay. Gavin, thanks. Jasmine, Shalea. Who else we had? Oz. Okay. Okay, and I got, okay, 12, 13 out of 21. Okay, I got, let's see, Gavin, Aaron, thanks, Aaron, and Ty. So it looks like we got more people saying electrons, and it is actually protons. Protons. I know, there's so many things that they say the atomic mass is P plus N. Protons plus neutrons. Okay, so this by itself is the protons. And remember, this is its DNA. So if you change that, you change this, it changes to something else. So 6 goes to 7, it becomes nitrogen. 7 goes to 8, it's an oxygen. It's a totally different element. Here is something you write with your pencil, and here you're breathing this stuff. So just by adding two more protons to it makes that big a difference. Okay, so what's the difference between the two carbons? Okay, so what is the difference between the two carbons? Is it the proton or the neutron here? Is it the proton that's different about this? Or is it the neutron? Let me see if I can write this. Neutron. Proton or neutron. So A is proton, B is neutron. So what is the difference between these two? Is it A, the proton, or B, the neutron? Okay, this is pretty important stuff. Proton or neutron. Thanks, Gavin. Thanks, Madison. Thanks, Shalea. Thanks, Haley. Thanks, Kamaya. Thanks, Mariana. All right, we got Jeremy, thank you. All right, so Aaron, thank you. Okay, so let me see what we got here. We've got a split. So the difference between these two, so I'm publishing this poll. Let's look at the poll here. Not look at the poll here. Okay, so public chat. Okay, so this one says 50-50 here. All right, so the difference between these two is the 13 and the 14. Notice that the sixes are the same. The sixes are the same here. So this one is the same as that one. So, and that's why we put the letter C here, because the isotope, iso means the same, in the same place. So the same in the same place is same place in the periodic table. So this is a carbon and that's a carbon. The difference here is that this is, what am I writing here? I have no idea. So 13, that's what I was writing, minus 6 is 7. So 7 neutrons, because we have the 6 protons here. 13 total, 13 neutrons, 13 total, minus the 6 protons gives me the neutrons. Here is 14 total, neutrons plus protons, equals 6 protons plus 8 neutrons. Okay, so that's the only difference between an isotope, is that the neutrons, and you can add as many neutrons as you'd like all day long, and you're not going to change the element. It's not going to change what it looks like. It may become radioactive, or unstable, but not a big deal in terms of what it is. Okay, so here's the definition. Isotopes, atoms that are the same number of protons, but have different numbers of neutrons. Atoms that have the same number of protons but have different number of neutrons. So here's hydrogen. It comes in 3 flavors. One without any neutrons, just a proton. One that comes with a proton and a neutron, deuterium. One that comes with a proton and 2 neutrons, which is tritium. They use this in nuclear research. Okay, they use these, and there are not very many of these in hydrogen. There's not many of these. All right, so they're very rare, but they are there. Okay, so let's look at the terminology again, one more time. The atomic number is the lower number or the smaller number. Okay, again, there's an exception for hydrogen. 6 is on the lower. The mass number is up on top, because sometimes they switch them. And the number of protons is equal to the number of the atomic number. So if they say atomic number, you think of protons. So atomic number, you think of protons. Okay, 6, atomic number 6, number of protons. Okay. So let's look at some of the way they talk about these, identifying isotope notation. All right, using the atomic notation, example, 12,6C or simply 12C. Right, so they're just using the mass. Okay, this is new to you, simpler but less information, right? Simpler, they just say 12 carbon. So example, mass notation, carbon 12 or C12. This gives only the mass. Remember the mass. Okay, I'm going to ask these questions again. So let me do this. Poll again. Let's see how you're doing here. Okay. So this one is ABC. Okay, the mass, atomic mass. Right, is it E plus N, protons plus neutrons, or is it protons plus electrons, P plus E, or is it electrons plus neutrons? All right, so let me get rid of this. Which is it? Okay, quickly now, tell me which of these is the correct one. If we're talking about atomic mass, are we talking about protons plus neutrons, protons plus electrons, or electrons plus neutrons? All right. All right, atomic mass. All right, so I got Jeremy. Thanks, Jeremy. So this is helping me, guys. Okay, Kamaya. Thanks. Madison, can I get some more people in there, please? Give your vote. All right. Thanks, Madison. Where did you go? You guys switched on me here. Where'd Madison go? Okay. All right. And I got Kamaya, Jasmine. Okay. Now I've got Christian. And I've got Gavin. And I've got Haley. And I've got Mariana. And I've got Shalea. And I've got Ty. Okay, I've got 12 out of 19. Okay, how about you, Luli, or Shayana, or Kaylee, or Joseph? Can you guys put a vote in there real quick? It really helps me out. Let me know. Nobody else? Going once, going twice, going 3 times. People walked away. Okay, so what we've got is it's protons plus neutrons. And 5 people got that. A lot of people are saying protons plus electrons. Okay, so we need to really go over that carefully, So atomic mass is protons plus neutrons, or protons plus neutrons. So here is the first element that they discovered that came in 3 different flavors. Okay. Oh, does that happen now? Yeah, don't want them to choke on something. Thanks, Shayana. Thanks, Oz. So neon came in neon 20, neon 21, and neon 22. All right. So think of it as a pair of shoes. They're all the same type of shoe. Okay. But maybe neon 20, which has 20 protons and 20 neutrons, that's where the 20 comes from, is a little bit different from the neon 21. Maybe the color is a little bit different. Okay, neon 21 has a different color, but it's the same style of shoes, it's the same company that makes them. And neon 22 is the same thing, but it has a different color yet. Okay, but if you think about neons, they're the same thing. It's still the gas that makes a neon sign, but the mass of them. So basically saying that the shoe is heavier, right? You bought a heavier shoe, but it's the same thing, right? So here it is, or more mass. So the protons and neutrons are changing here. The electrons are staying the same. The protons are staying the same. Okay, if the electrons change, then it would become an ion. Ions refer to the difference in electrons, the charge on them. So we're looking here because the electrons and protons match. That's a neutral charge. Neutral charge. I know I'm talking really a lot here, guys. We're almost done. Okay, I'm going to have you do some practice here. Okay. All right, so hydrogen comes in 3 flavors: hydrogen 1, hydrogen 2, and hydrogen 3. Okay, the protons are the same. 1, 1, 1 at the bottom. The mass number at the top changed. 1, 2, 1, 1, 2, 3. Okay, so let's take a look at this. Let's do this together. Let's try some carbon. Okay, so let's work on this together. Let me get you guys so I can take a look who's gonna get points for today. I know you guys, it's a lot of work today, a lot of work. Okay, so let's go on this one. So carbon 11. Okay, remember, that's the mass. The mass of carbon is 11. Okay, all right, so we know the proton is 6. We know the electron is 6 because when they're equal, it's 0 charge. Okay, so take 11 minus 6, that gives you 5 neutrons. 11 minus 6 gives you 5 neutrons. Okay, so 6 protons. So we got 12 minus 6 gives us, and then 13 minus 6 gives us the neutrons, and then 14 minus 6 gives us the neutrons. All right, there you go. Thanks, Madison. You're the only one there so far. I lost everybody. Everybody had to go somewhere. Too much work today. I know, you guys, it's a lot of work today. I really appreciate you being in there. It really helps me out, helps me know what you know. Okay. Couple more slides, ladies and gentlemen, couple more slides. I promise. So Madison's the only one in here today, huh? Okay, Madison. You and me. All right. And did I get anybody? Oh, I got a few people. Kamaya, I knew you wouldn't forget me. Thanks, Madison. Thanks, Kamaya. And who else? Mariana. Thanks, Mariana. And that's it. Just 3. Nope, I got one more. Madison, Kamaya. Oh, okay. Oh, there we go. Shayana, where are you? There we go. There we go. Okay, so you got 5. Then we got 6. 12 minus 6 is 6. Oops, put it down there. 6. 6 from 13 is 7. And 6 from 14 is 8. So the neutrons are different. Neutrons are different here. Did I get anybody else? 1, 2, 3, 4. Oops, I got a couple more. Jeremy, thanks, Jeremy, and Jasmine and Gavin. All right. Jeremy, Jasmine, and Gavin. Jeremy, Jasmine, Gavin. Okay. And Jasmine R. Jeremy, thank you, Jeremy. All right, so that's what we got there. So let's do this. Let's move on here. Okay. All right, so let's try this one more time. So 1 minus 1. So 1 minus 1. 2 minus 1. 3 minus 1. That's what we're doing. 3 minus 1. Put those numbers in there. Thanks, Madison. Thanks, Jasmine. Mariana. Mariana. And who else did we get here? Shayana. Shayona, where are you? There we go. Thanks much. And we got Ty. Ty came back to us. Thanks, Ty. Anybody else? Did I miss anybody? Mariana, Madison, Kamaya. Oh, there we go. Got Kamaya. Some people got 3, Jeremy, and yeah, did I get you, Jeremy? Nope, I didn't get you. All right. Some people got 2. So we got 1, this is 0, this is 1, and this is 2. Okay. Now, this is the big thing here about, all right, so let's go. Talked about carbon, 6666, 678, subtracted them 6 electrons each. Okay, so what I want you to do on this particular one, all right, which of these are the same? So let me tell you this. Okay, so let me go with this one. This is the number of protons. This is the atomic number. Atomic number. So this is the atomic number. Okay, this is the atomic mass. Atomic mass. Okay, which is protons plus neutrons. Okay, so which of these, so let's match one of these. So there are pairs, so we're matching, matching him. So I'm going to circle this one. Tell me which one is the same element as this one. The same element, that's what we've been talking about, isotopes, the same element, different number of neutrons, same element. So circle that one and circle something else. Which one, what other one is it? Circle 15.8 and then circle another one. Tell me what that one is. 15.8 and what other one? Okay, you don't have to write the notes down here. Just circle this one and then find another one. Circle this one and find another one that's the same. There's one more in there, just one more. One more. Okay, got to put another circle. Is it this one, 15.7, or is it 12.6, or 14.6, 15.7, or 16.8? Which one? All right. Remember the DNA about the atomic number is the proton here, the proton. So I don't see anybody getting this. So this one is the one, 16.8. So this number doesn't have to match. This number right here has to match. This number here has to match. Okay, so let's use a different color. So 15.7 matches with which one? 15.7 matches with one. 15.7 matches with which one? Use them different color. There you go. And 12.6 matches with which one? Okay. All right, so I'm going to have you guys do this real quick here. Just kind of bring it home a little bit. We got 5 minutes left. I know we used a lot of time, but we were trying to go kind of slow because it's new information. All right, so we're going to go here, and I'm going to give you your modules here. Clear out the chat here. Okay, so modules. So if we go here, what I want you to do, word wall, Here's the link. Here's the link. This is bonus points here. So click on that, put this in here. Now it says you don't have to take a screenshot, just say I'm done and submit. Okay? So click on that. Tell me if you're in. Start. This is the start. Make it large. Make it as large as possible because these things here. Now, remember, just like we did before, okay, the bottom number, 7, 4, has to match with something that has a 4 on it. So this one, 7, 4, and 9, 4 match because this is the number of protons. This is the number of neutrons and protons. So it doesn't matter if those numbers on the top don't match, but the bottom numbers of protons do. All right. Okay, so quickly take that last 3 minutes, finish these up, submit it, and then just say, I'm done. Okay, when you're done with this, you can leave. All right.